Okie doke, here we go. Here's your review sheet for Monday. I'm going to do half the problems, we'll say, if you guys see that right now. The rest I'll leave for you to do on Monday here. If you have any questions about this review sheet, you can reach out to me on Tuesday. Don't forget your test will be on Wednesday on Castle Learning. So that will be how we're doing things this week. Okay, first questions here say, determine whether the things are linear or not. Well, is this a perfectly straight line? Does it twist and turn and curve? If it stays perfectly straight, it's linear. Does that curve? It does. So it's non-linear. Is that one straight? You should know what it is, whether it's linear or non-linear. Number 4, is it perfectly straight or is it squiggle all over the place? Well, if it's not a straight line, it's not or non-linear. I'll leave the other two ones for you to do there. Part B has multiple choices. I'll do one, you can do the other. It says, which one's nonlinear? Not a line. Is that a line? Straight line? Yes. Is that a straight line? Yes. Is that a straight line? Yes, because they don't squiggle. That one turns and squiggles a little bit. This one's nonlinear. And you can do number 2 by yourself. On the back, you had a little trouble with this when you had equations. What I do is I go, look at the y, look at the x. Do they both have power 1 above them? They do. So it's linear. Look at number 3. Is there power 1 above the x and the y? It is. So they're linear. Look at number 5. Is there power 1 above the y? There is. Is there power of 1 above the x? Oh no, it's something different than 1. Therefore it's nonlinear. Look at this here. Is there power 1 above the x? Yes. Power 1 above the y? Yes. Linear. We're going to do part B down here against multiple choice. You have 2 different questions. Which of the following is linear? Power 1, power 1. Oh, no, that's nonlinear. I'm looking for linear, which means power 1 above both. Power 1, yes. Power 1, oh, no. Power 1, yes. Power 1, yes. Power 1, yes. Oh, but what's x times x? That'd be x squared. That's going to be nonlinear. So that's actually a tricky one right there. But look here. Is that power 1? Is that power 1? Sure is. That one's linear. Okay, on your next page, you can do these now, the way we just did the last page. This is page 3 here. On the back of this, we want to compare functions using your tables, or your graphs, or your equations. So what you have to do is find the slope for each, and whichever one is bigger has a greater rate of change. Whichever one is lesser has a smaller rate of change. Okay, so right here, if I look at this here, I box it in from this point to that point, and I find my delta y and delta x. Delta x goes the same direction that the x-axis does. That was 1, 2, 3 boxes. And here, delta y goes from 12 to 0, which is 12 boxes. Delta y is 12, delta x is 3. Remember, slope is m, which is always delta y over delta x, which means you put your delta y value of 12 on top. X on the bottom is 3, so function B has a slope of 12 over 3, which is worth 4. Now, if this slope for A is bigger than 4, it'll have a greater rate of change. If the slope for A is lesser than 4, it'll have a smaller or lesser rate of change. If it happens to be exactly 4 and matches it perfectly, then they have equal rates of change. So here we go. How far from negative 20 to negative 18? You go up 2. How far from negative 18 to negative 16? You go up 2. How far from negative 9 to negative 6? You go up 3. How far from negative 6 to negative 3? You go up 3. These are my x values, so these are all my delta x's up here. These are all my y values down here, so the 2's are my delta y's. Remember, delta y goes over delta x, so the slope for function A is delta y of 2 over 3. This is 2 over 3, so the slope is 2/3. The slope is also 2 over 3, so it's still 2/3. They're the same. What's bigger, 4 or 2/3? Well, 4 is bigger. But they want which one is lesser. A is smaller, because 2/3 is smaller than 4. As for the y-intercept, you have to see where they cross over here. So I'm not going to have you do that just yet. We'll handle that on the next page. If I look at number 2, again, I have a point here and a point here, so I box it in and see what I got. 3 down to 0 is a change of 3. Now your scale down here goes from 0 not to 2. Even though it's 2 boxes, it goes from 0 to 6. That's a 6 there. So delta x went along the x-axis. That's going to be delta x is going to be 6. This went up and down, which is delta y. So for this, delta y of 3 over delta x of 6, 3 over 6 is going to be my slope for function a, which is a half, which is 0.5. When you have something like this, f of x is a fancy little term. It's just the y value. Equal to negative 5/4 of x minus 13. Whenever my equation gets y all by itself, the number in front of the x is your slope, which is just negative 5/4. Which is, if you take out your calculator, and you type in negative 5 divided by 4, you get negative 1.25. Now, which one has a greater slope? The greater slope is 0.5 bigger than something that's negative. It sure is, and that'd be A is your answer. If they got a little bit tricky and say which one's the greater rate of change, you would then just ignore the negative sign. Greater slope, you have to use the sign, and 0.5 would be the answer for the greater slope. If they say greater rate of change, you ignore the sign and say which number is bigger inherently. Is 1.25 bigger than a half? It sure is. And you have to do it that way. Okay, I'll leave number 3 for you guys to do. Okay, that was the other side of the other page. We did that already. You also have, this is your third page, where you have to compare the functions. So we did all that. On the back of that page, we have identifying slope and intercept. And I'll do the odd ones for you there. As long as y is by itself, the number in front of the x is your slope. So here, my slope is 1. Because really in front of that x, it's 1x. What's my y-intercept? The other number that's after the x. My y-intercept is positive 8. Here, my slope is negative 3. My intercept is negative 6. Slope is 2. Intercept, negative 1. Slope, negative 9. Intercept, negative 5, and so on. I'm sure you can do the rest of the page without me explaining that. And then your last page, again, types of slope. Well, if you take your pen and lay it on top of the line, is my pen pointing downhill or uphill? It's going downhill, therefore it's a negative slope. If it goes uphill, it's a positive slope. If it goes straight up and down, it's undefined. If it goes straight across, it's a 0 slope. That's how you do this page. And to the back, if I want to write an equation, if I give you the slope and I give you the intercept, remember, every equation has y and x in it for linears. In order to put the equation together, if I give you the slope, it goes in front of the x. So slope number goes in front of the x. Intercept number goes after the x. Y and x, slope number goes in front of the x. Intercept number goes after the x. Why did I put a plus sign there? Because it was positive 4. And you should be able to do the rest of the page knowing that. Okay? So work on the 4 pages. I'll post solutions to that sometime late on Monday. If you have any questions beyond that, we can go over things on Tuesday, and your test again will be Wednesday on Castle Learning. Don't forget you also have a quiz due on Tuesday as a review, which comes the day before your test on Wednesday.